Hi and welcome to this on Maths prediction for the Edexcel Paper 1 Higher Tier Maths GCSE November 2020. Enjoy! Hi and welcome to this on Maths prediction for the Maths GCSE November 2020 series. So this is a really strange year, as I'm sure you're aware, that we haven't had a GCSE paper in the summer. This paper will be the first GCSE paper almost all of you will have sat, with the exception being Year 13 students who are resitting the Maths GCSE. So it's really, really important that you are prepared, both in your knowledge of the subject and just to your knowledge about how the exam works. And this is what this prediction is supposed to be used for. Please don't 100% rely on this prediction. First of all, the accuracy has been good in the past, but it's never 100%. There's always topics that are not predicted that come up in the actual paper. So make sure you do your revision. What some students do is they do this test now, see how far they can go with it, go off and revise, and then do the test later on to see whether they've improved their marks. And the way they can do that is, you can do it too, is if you go to onmaths.com, you can try this paper online for free. The numbers change each time, so you're not just remembering answers, you actually have to work them out. And it will give you a grade as you go along on the paper, just like this video. So you'll see exactly what grade you are at each point of the paper. We've got loads and loads of other stuff on the website. I'm not going to go into it, but there's loads and loads of stuff that you can also do. And if you click up here, which I think is there, it will take you straight through to the correct paper, so you can just get started straight away. If you want to sit back and just watch how to do the questions, feel free. If you want to give that a go first and then come back to this video, there's a link to this video in the actual GCSE paper on our site. Without further ado, I should say everything is completely free. You are not charged for anything on onmaths.com. So, let's get started. Whenever you're multiplying, subtracting or dividing with fractions, you must always convert them into improper fractions if they're mixed numbers. So here we've got two mixed numbers. We've got 6.5 and we've got 4 1/3. So we need to convert these into what we call improper fractions, top-heavy fractions. And we do that by timesing the big number by the bottom number, then adding it to the top. And we do that for both of these. So I'm going to do 6 times 2, which is 12, plus the 1 at the top, which is 13. And it's going to be over 2. Then I'm going to do 4 times 3, which is 12. Add to the top, which is going to be also 13, this time over 3. Now, when the denominators are different, when we add or subtract, we've got to get the denominators the same. So I look at this fraction here, and what am I going to times top and bottom by to get it the same as this one? We're looking at the bottoms. We've got 2 and a 3, so we've got to find the first number in the 2 and the 3 times table, which is going to be 6. So we're going to times top and bottom here by 3 to get that 2 to a 6. We're going to times top and bottom here by 2 to get that bottom to a 6. So 13 times 3 is going to be 39 over 6. And 13 times 2 is going to be 26. And then 3 times 2 is 6. Now we just simply subtract the tops, which is going to be 13. And then put it over the same denominator as we've had in the two fractions there, so it's going to be over 6. So we need to make it a mixed number in its simplest form. So we ask ourselves, how many 6s can I take away from 13? Well, I can take away 2 whole ones. How many remainders do I have left? Well, 6 times 2 is 12, so it's going to be 1 remainder, and the bottom of the fraction stays the same. So it's going to be 2 and 1/6. For this second question, we need to convert these into top-heavy fractions or improper fractions, like we did before. So 5 times the 4 is 20, add to the top 21 over 4. And 3 times 3 is 9, add to the top is 10, keep the bottom the same. Now here we have this 3-letter acronym, which for some reason all the students remember. It's KFC. I have no idea why people remember that. So what KFC stands for is keep, flip, change. Some students remember it as KCF or same, change, flip. Whatever works for you, stick with it. So we've got 21 over 4. Keep that the same. Change the divide sign to a times, because you can't really divide with fractions, so we change it to a times. But to do that, we need to flip the second one. So it becomes 3 over 10. Now, what we're going to do now is we just simply times the tops and times the bottoms. And that's all we've got to do. So it's going to be 63 over 40. So again, we want to leave it as a mixed number. So how many 40s can I take away from 63? Well, 1. And when I do that, I'm left with 23 over 40. Now 23 is a prime number, so unless 23 goes into 40, which it doesn't, that is our simplest form. Okay, so we're asked to factorise, which means put this into brackets. So the first thing I would do is put a set of brackets down. It's a quadratic because there's an x squared, an x and a number term. So I'm always going to put 2 sets of brackets. And because it says x squared there, and there's no number before it, the first 2 terms are going to be x. That's the nice easy bit. The slightly harder bit is working out what comes second in each of the brackets. So we've got to look at 2 numbers here. The number before the x is going to be our addition number, and the number left at the end, which is a positive 28, is going to be our multiplying number. So we need to find 2 numbers that add together to make minus 16 and times together to make 28. Now, the only pair of numbers that times together to make a positive are 2 positive or 2 negative. Now, if we had 2 positive numbers, we can't add them together to make negative 16. So something we do know right now is that both the numbers are negative. Now, we can take that out of our mind now. We don't need to worry about the negatives. So we're looking for 2 numbers that multiply together to make 28 and add together to make 16. Okay, remember, we're not thinking about the negatives for this anymore. So we're going to write down the factors of 28. So 1 times 28 is 28, but they add together to make 29. Well, that's not correct. We need to get 16. So 2 and 14. So let's add those together. That makes 16, so that's correct. Now, we obviously know that they're minus 2 and minus 14. So it's minus 2 and minus 14. Now, a common question is, does it matter which way around it is? Well, if you think about it, 2 times 3 is 6, 3 times 2 is 6. They're both equal the same number. Okay, so it doesn't matter which way around you multiply something. So with the same with brackets, you could write x minus, in fact, why don't I write that as my answer? X minus 14, x minus 2. It doesn't matter which way around they are. Okay, so this is quite a complicated question because there's 2 ratios and they're talking about slightly different things. We're also given an amount of one of the sides of the ratio, or one of the sides of one of the ratios, and we're asked for the amount of the first side of the ratio. So it's all a little bit complicated. But the way I'd like to start these things off is by just writing down what I know from the question. So we've got football, rugby, and we've got tennis. So football to rugby is 4 to 3, and rugby to tennis is 6 to 13. So these 2 ratios here are kind of incompatible at the moment. Got this one here, which is linking the football and the rugby, and we've got this one here, which is linking the rugby and the tennis. What I'd like to be able to do is kind of like put the 2 together and make just one ratio. So if you notice from the one I've put around a blue square or blue rectangle round, we've got the rugby as 3 parts of that, but in the green one the rugby is 6 parts of that. So what if I times both of these by 2? If I times both of them by 2, I get 8, to 6, and that actually matches the other ratio. So what I can then do, because it's the same parts of rugby, I can then say that it's 13 parts tennis. Okay, so all I'm interested in here is matching these two up to make these both the same. So I times the one in blue by 2 and it made it exactly the same. Now it says that 39 students picked tennis, so I need to find some way of getting the tennis to be 39. Well, that's going to be just simply timesing it by 3. And if I times that one by 3, I've got to times this one by 3, and I've got to times this one by 3. So 6 times 3 will be 18. And 8 times 3 will be 24. So we've already answered the question, because if there's 39 tennis, there's going to be 24 football. This is not the easiest question, or ratio question out there, but if you just try and link the two ratios together, then it will start to make sense and it will start to become a lot easier.
Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right, because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 5s are 50 and 4 5s are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900. That's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for 1 child, so that's 1 child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80. So that's going to be £51.80. Okay, I'll move down a bit. And let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. First thing we need to realise with this question is which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left, so 2 left, and let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4, so 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. Okay, so we're asked to solve these simultaneous equations, and the first thing to notice is that the coefficients of the x and the y are different. We've got 3 and 4 for the x and -3 and 6 for the y. So looking at that, I could times the top by 4 and the bottom by 3 to get the x's the same, but all I need to do is times the top by 2, so I'm going to do that. So 6x minus 6y equals 30. I'm just going to copy in the other equation underneath. Okay, so with simultaneous equations we work downwards. So I'm just going to highlight that. It's always useful to highlight it. And the rule is that if the matching coefficients have the same sign, we subtract. If they have different sign, we add. So looking at this, they have a different sign, so we're going to add, okay, because you've got -6y and positive 6y. So 6x plus 4x is 10x. -6y plus 6y is going to be nothing, which is good because we need it to be nothing. And then 30 plus 10 is 40. Next, go put the lines in, and we're dividing both sides by 10. So x equals 4, and that's only half our answer. We need to substitute that into an equation. I'm going to pick the top one to find out what y is. So we've got 3 times 4 minus 3y equals 15. And I'm just going to put the lines in. So that's going to be 12 minus 3y equals 15. Now the minus 3y is going to be a problem, so what I could do is I could add 3y to both sides at this point and then take away the 15. I'm going to carry on though, so I'm going to take away 12 both sides. So we've got minus 3y equals, 3. Now at this point, if I divide both sides by -3, it's kind of like dividing by 3, but it gets rid of the minus on the left hand side and it introduces a minus on the other side. So 3 divided by 3 is 1. So that's -1. Now at that point, if you ended up at this point and you don't quite understand what I did there, something you can do is just times both sides by -1, and what that does is it just flips the sign. So it makes the -3y a positive 3y and the positive 3 a -3. So everything switches sign, and then you can just divide by 3 both sides of y equals -1. Whichever way you're most comfortable with. Now I can check this by putting it into the second equation, and what is it, 16 take away 6 equals 10, so we know it's right. Okay, so we asked Hannah's invested some money in the bank, and she uses a formula to work out how much money she's given after a certain amount of years. So the 2,200 here is the amount of money that she had. The n here is the number of years, and the m is the amount in her account. So the only thing that really hasn't been discussed is this number here. This number here is a multiplier. So to find a multiplier, you start off with 100%, you add on the percentage increase, and then you divide by 100. So we just go to the other way. So we're going to start off with the multiplier. We're going to times it by 100 to get the percentage. So it's 101.1%. And then what we're going to do is just take away 100%, because that's the initial amount, and see what we've done to it. Well, we've increased it by 1.1%. So that shows a 1.1% increase. Okay, so this is quite a complicated looking question, but the most important thing is we break it down. So it says a circle is drawn inside a square. Square has a height of 12 centimeters. So the first thing to notice is it's a square. Therefore, the width is also going to be 12. And be careful to look out for that. Whenever you've got a square, they might only give you one of the dimensions. They won't always say it's a 12 by 12 square. Okay, so you've always got to assume that the other one, or you've always got to know that the other side is going to be the same. Okay, it says work out the shaded area. So the thing we notice is it's like a quarter of the square, but with the circle removed. Okay, so the first thing to do is work out the area of the square. So area of square. Okay, so the area of the square is going to be quite easy. It's going to be 12 times 12, which is 144 centimeters squared. Okay, next thing to work out is the area of the circle. Okay, now this you need to remember the formula, which is pi r squared. Okay, and that you do need to know because you're not given that in the exam. So it's going to be pi times, and now what is the radius of that circle? So the radius is halfway across the circle. Now the circle has the same height as the square, or the same diameter as the square's height. Okay, so the radius is half of that, so it's going to be 6. So it's going to be pi 6 squared. 6 squared is 36, and we write that as 36 pi. Okay, now it's an uncalculated question, or it could be in the non-calculator, it could be in either. Okay, but it does ask us to give our answer in terms of pi, so we're not going to go any further than that. We'll leave it as 36 pi. Okay, so we need to work out the area of all of the outside. Okay, so we're going to do all of the outside. Okay, including this shaded bit. Okay, so area outside circle. So I'm trying to show the examiner that I'm working out the area that I've shaded in red. So the area of that is the area of the square, which is 144, take away the area of the circle, which is 36 pi. Okay, now to work out the shaded area, which is what the question asked for. Now looking at that, we've got 4 parts. We've got this part, this part, this part, and this part, and all 4 of them are equal, and we only want one of them. Okay, so to work out the shaded area, we get our answer from before and we divide it by 4. So we're going to divide the 144 by 4, and it's dead easy to divide by 4 because you halve it, then halve it again. So half of 144, well, half of 140 is 70, half of 4 is 2, so that's going to be 72. then half of 70, half of 72 is going to be half of 70, which is 35, half of 2, which is 1, so it's going to be, what did I say, 36. So it's 35 plus 1, which is 36. Okay, next we're going to halve the 36 pi. So we only need to halve the number before the pi, and that would have the same effect. So we're going to halve 36, or we're going to divide it by 4, but we're going to halve it first, which is 18, then halve it again, which is 9. So we need to divide each one by 4. So I've divided that by 4 to get to 36, and I've divided that by 4 to get to 9. So my answer is 36 take away 9 pi. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here, and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start, and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether, and there's 3 reds and 7 altogether, and that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle. So 89.6. Now it says it's to the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values. Put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c. And I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c. And we're going to take away 9 from both sides. So it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c, which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x and see whether you get 17. 3 times 3 is 9. 9 plus 8 is 17. Okay, so this looks like a quite simple question, however it's a little bit more complicated than it looks. It says that the sum of 3 consecutive numbers is divisible by 3, and we've got to prove it, so the working out is everything. So I'm going to name my first number x, okay, because we don't know what it is, it could be anything. But the next number will be x, same as the number before, but 1 added to it. And the next number after that is going to be the same as the first number, but 2 added to it. And it says the sum, so what we're going to do is we're going to add these 3 numbers together. So x plus x plus x is 3x. 1 plus 2 is 3. Now this hasn't proved that they're divisible by 3 yet. All I need to do now is factorise this out. So I'm going to divide each of those by 3. Now that now is proof that they are divisible by 3, because if you times any number by 3, it will be in the 3 times table. So my proof is this bit here, and I could write a sentence saying any number that I times by 3 will be divisible by 3. And on the site, that's all you need to put in. Okay, so we're asked to show the inequality x is greater than or equal to 3.5 on the graph. So first thing to do is draw the line x equals 3.5. So that will be a line where x is 3.5, and it goes up the entire duration of the graph, so it'll be about here. So that's the line there, and it's either on the left hand side of that line or the right hand side of that line. So it asks us just to label it R. Sometimes they ask you to shade it, but they seem to be happier with labeling as R, because some people shade out the region they don't want and some people shade the region that they do. So they ask you to label it with an R. So it says x is greater than or equal to 3.5, so that R can be anywhere on the right hand side of that line. It has a little line underneath it here that says it can be equal to it. If it didn't have that line, then the line I drew would have to be dashed. Okay, with this question, I would probably start off by identifying the fact that we've got an isosceles triangle here, because they're both radii, they must be equal. Therefore, this angle here is 40 degrees, and this angle here, well, we're going to do 180 angles in a triangle, take away 40 times 2, that's going to be 100 degrees. And you need to write down your answer the fact that you've identified it's an isosceles triangle and you've taken away from 180 because of angles in a triangle. And then to find x, well, we need to use a circle theorem. Circle theorem says that the angle on the circumference angle at the centre is twice the angle at the circumference. So this 100 degrees in the middle is twice the angle at x, so x is going to be half of it, working the other way around. And the reason is angle at centre is twice the angle at circumference. So that all you need to do is find the angle at the centre and then halve it to find the angle at the circumference. Okay, so here we've got a box plot, and it's important to understand the parts of a box plot. There are always 5 parts. We've got the lowest value, which is the start of the box plot. We've got the lower quartile, which is the start of the box. We've got the median, which is, if I can line it up right, which is the line in the box. Then we've got the upper quartile, which is the end of the box. And then we've got the highest value, which is the end. So when it asks us for the median is halfway between 10 and 12, which will be 11. And it will ask us for the interquartile range. Interquartile range, IQR for short, is the upper quartile, take away the lower quartile. So the upper quartile here is 18, and we're going to take away the lower quartile, which is halfway between 2 and 4, which will be 3. So it's 18 take away 3, which is 15. Okay, now next it says that the table shows results of cats, I think the first one was dogs, and compare the two distributions. Okay, you must always compare the medians. So looking at my dogs, or looking at my answer to the dogs, it was 11, and the median here is 15. So you need to write a sentence saying that the median for cats, which was 15, is higher than dogs, which is 11. So always state the values. Now you can also say on average they're higher because the median is 15 for the cats and only 11 for the dogs. As long as you're comparing the medians and saying which one's higher, or maybe they're the same. Okay, the interquartile range for the cats is 23 and for the dogs is 15. And the next thing you need to compare is a range. Now you could pick the overall range, or it's probably easier just using the interquartile range, and I've just done that wrong because the interquartile range for the cats obviously would be 23 take away 10, which is 13. That's very different. Right, so for the cats it's 13, for the dogs it's 15. Now 13 and 15 are not that far away, so you might say they are more or less the same, or you might say that the interquartile range is higher for the dogs. As long as you back it up with the numbers and say something that makes sense, then that's absolutely fine. The way of starting this sentence, so I said on average is kind of the way to start when you the sentence when you're comparing medians. For this one, you just say the spread of data for dogs is slightly higher than with cats. And then you would say, since IQR, interquartile range for dogs, is 15 and for cats is 13. So whenever you're comparing the medians, you really should start with on average and then say the medians and write a comparative comment. And always start the sentence when you're comparing a range or an interquartile range with the spread of the data. And it just makes you makes the examiner realise that you know what you're talking about. Always include the numbers as well, and that's really important on some of the papers that you're referring to something. The first comparison is always the average, so the median, when you're comparing box plots or cumulative frequency graphs, and the second one is always the range, and that's really important to remember. Okay, so this is an inverse proportion question. So the first bit I start with for this question is this line here. So as soon as I see that, I just write down B, and this fish symbol, which means is proportional to. The inverse is 1 over, so whenever it says inversely proportional or varies inversely, it's 1 over, and it says the square of A, so I'm just going to write A squared. Now I'm going to get my lines in. Okay, so to get that fish sign to an equal sign, I need to times the right hand side by K, so it becomes K over A squared. Now I'm going to pick a value of A and B. Now A and B are called variables, they're going to change. The K though is a constant. When we find K once, we found K for good. Now looking at these options, I kind of like this one the best. It's kind of simple. I like a nice simple fraction, 1/8 and 8. Okay, I can work with that. So it says B is 1/8, so I'm going to substitute in B is 1/8. And K we are trying to find out, and it says A squared, so it would be 8 squared, which would be 64. So I'm going to times both sides by 64, so I can find what K is. So it becomes 64 over 8 equals K, so therefore K is equal to 64 divided by 8, which is just 8. So putting that back into this equation here, or formula here, becomes this equation here. So B equals 8 over A squared. Okay, I'm going to use that to find out what A is when B is 2. So I'm going to write the same thing as I've written down for my answer here, but instead of B I'm just going to write 2. So 2 equals 8 over A squared. Get my lines down. Okay, so the first thing I'm going to do is times both sides by A squared. So the best thing to do is get rid of any brackets or fractions. And since that means divide, over means divide by A squared, I'm going to times by A squared, so it would be 2A squared equals 8. Then I'm going to divide by 2 both sides, so I get the A squared on its own. So it's A squared equals 8 divided by 2 is 4. Then I'm going to square root both sides. So this could be 2 or minus 2, but it does say positive value, so A equals 2. So if I put A as 2 into the answer to question A, it would be 8 over 2 squared, which is 4, so 8 over 4, which is 2, so B equals 2. Now, this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now, this equation here, up until this level, that used to be y equals 4x. And the question we have here would be, what is y when x equals 4? It's the same question, it's just a different way of writing it. So, all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question, just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the g to the 16. So we've done the f, and the f we did first because it's closest to the brackets. So whichever one's close to the brackets you do first. Okay, we've done the f. Now we need to do the g, and we just do exactly the same thing. So g of 16, we're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay, perfect. Right, the next one. This time it's important to notice that the f and g are the other way around. So it's g that we're going to be doing first, and then f. Now the thing we're feeding in is x. Well, you can't feed in x as x. Well, you can. It's just going to remain as x. So let's focus on the g first. So we're going to do g of x first. And now g of x is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now f wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the fg brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3.
Now these look like quite difficult questions. I'm just going to enlarge it a little bit. But this is just a matter of remembering a set of rules. And the rules are simply, whatever number at the bottom here means the root that you're looking for. And this is just the normal power. You start off with the root. So because it's a 2, it's going to be a square root. If it was a 3, you'd find the cube root. So we're going to find the square root of 16, which is 4. And we leave that power there. So it'd be 4 to the power of 3. And 4 to the power of 3 is 64. So the number at the bottom is the root. The number at the top is just a normal power. Always do the root first. There's another rule here. So it'd be minus 2/3. So like before, that's going to be the root. This 2 is going to be the power. And this minus here just means to find the reciprocal. And that's it. That's just a matter of memory. So there's nothing about a negative in the power that would make you think that you'd find the reciprocal of it. And there's nothing to do with the fact that the bottom is 3 would mean it's going to be a cube root. It's just a matter of practicing it and remembering it. So we're going to deal with the reciprocal first. And to deal with the reciprocal, all we need to do is put a 1 over it. So it'll be 125. We've got rid of that negative now, so it's just 2/3. So it's 125 to the power of 2/3, but all of that is with a 1 above it. If it was a fraction, so if it was a fraction in brackets, we would flip the fraction, but if it's not a fraction, we just put a 1 over it. Next we're going to deal with that cube root. So the cube root of 125 is going to be 5, and we haven't dealt with that 2 yet, so we're going to leave that there. And that 2 is just a normal power, so it'd be 1 over 5 squared, which is 1 over 25.
So histograms follow a triangle like speed, distance, time, but for histograms, frequency is at the top, frequency, density and class width are at the bottom. So we're asked to find the frequencies, and we've been given the class width and the frequency density. Now be careful, the frequency is proportional to the frequency density times class width. So always check to see whether the example given to you, if you are given an example, works. So the class width is 10 for this first one, and the frequency density is 0.8. So have a think, 10 times 0.8, well that doesn't quite work. That gives me 8. So I've then got to divide it by 4 to work out the frequency. Now I'll always divide each of these by the same number. So the class width for this second one is 10, and the frequency density is halfway between 4 and 4.8, so 4.4. And so what I'm going to do is 10 times 4.4, which is 44, and I'm going to divide it by 4, which gives me 11. And the last one, the frequency, the class width, and you've got to be careful because it's not always the same with histogram, is 5. The frequency density is 3.2, so I'm going to do 5 times 3.2, which gives me 16. Then again I'm going to divide it by 4, which gives me 4. So just be careful, most histograms, this number here is 1, so when you times the class width and the frequency density together, you always get the frequency, but it doesn't have to be that way. Okay, so with this question we're first told to complete the square, so we're going to do that. But this time we've got a minus here, so we've just got to be careful of that. The first thing I would do, and this is not the only way of doing this, but I would remove or divide out that minus from the first two terms. So it becomes x squared minus 10x, all in brackets with a minus before it, plus 7. So I'm going to complete the square with that x squared minus 10x now. So we've got x minus 5 squared. Now that gives us the x squared and the minus 10x, but it also creates a 25, which we need to get rid of. So we're going to minus 25 there to get rid of that, and then plus 7. Okay, so we're going to remove that minus 25 now from the bracket. So we're just going to have the x minus 5 squared inside that kind of minus bracket. Now when we do that, it becomes a plus 25 because it's multiplied by the minus 1 effectively outside the bracket, so it makes it positive, then plus 7. So we've got minus x minus 5 squared, and then 25 plus 7, which is 32. Okay, so when doing this kind of question, always compare it to y equals x squared, sorry. So let's draw y equals x squared. So this is y equals x squared here, roughly. Now there's two things we notice. First thing we notice is it's upside down, Okay, so we're going to have a minus before the x squared, but we also notice the minimum point here is, or the turning point is at 0, 0. On A, it's a different place, and the question asks us, well, where is it? So, looking at this, we're going to compare this with our y equals x squared, and you notice straight away that inside the function we're minusing 5. Now, you need to brush up on your graphic transformations if you don't know this, but when you subtract inside the function, it goes the opposite way to what you'd think. So instead of going left 5, which you'd assume, it goes right 5. So the coordinate will be at x equals 5. Okay, so the coordinate is x equals 5, but we need to find out what y is. Now the best way of doing that, and there are other ways, is just feed it into this equation here. So you're going to do minus 5 squared, so minus 5 squared plus 10 times 5 plus 7, which equals 32. Oh, I don't know why that's come up. Let's remove that. Yeah, nice black, right, 32. Now let's have a look. Well, that looks roughly right on the sketch. It is above the x-axis. And you might think, well, hang on, why is R1 upside down? Well, R1's upside down because we've got a negative there, which flips it on the x-coordinate, on the x-axis. And then that 32 moves it up 32. So that's why. There is a way, you can just look at the function to find out what y is, but it's normally a lot simpler just to put the x into the equation, and then you guarantee that you've got the right answer. Okay, so we're asked to find un, which is just the nth term, and the first thing we do is work out what the sequence is going up in. So I need to add 15 there, then I need to add, 25 there, and then 35, and then 45. So the differences are changing. Now this means that it's it's definitely not a linear sequence. We don't quite know what it is yet. So what we then do is find the differences of the differences. Well, that's 10, that's 10, and that's also 10. Now when you find the differences of the differences and it's constant, it means you've got yourself a quadratic sequence. Now the way of dealing with this is you get that difference of differences and you halve it. You always halve it. That 2 hasn't come from anywhere, it's just the method is you halve it and you get 5. That 5 you get there, we know will be before an n squared. Now the way of doing this now is to write out the sequence of 5n squared. So let's do ourselves a little table down here, and we're going to have our sequence up on the top, so it's 25, 40, 65, 100 and 145. Let's extend that line a little bit. Okay, so that's our sequence, and we're going to write down the 5n squared sequence. So the position of the first one is 1, so 1 squared times 5 is 5. 2 squared is 4 times 5 is 20. 3 squared is 9 times 5 is 45. 4 squared is 16 times 5 is 80. And 6 squared 36 times 5 is 125. Okay, now you might notice something about how I said 6 squared. 5 squared is 25 times 5 is 125. Okay, so you might notice about how to get from the sequence given to us in the question to the 5n squared sequence. And you will notice that all we need to do is we need to just add 20 to each term in our sequence. So if we add 20 to 5, we get 25. Success. If we add 20 to 40, if we add 20 to 20, we get 40. If we add 20 to 45, we get 65. 100 and 145, so success. So our sequence will be 5n squared plus 20. Now we've got to be a little bit careful because there is a more complicated form of a quadratic where you can't just add an amount to each of these to get the quadratic. Okay, so this is quite a nice one, the fact that we can just add 20. On the next ones, on the more difficult ones, you need to find the nth term of this linear sequence. Okay, so we're asked to solve this by completing the square. Now when we complete the square, the bit we're interested in is this first bit, and that minus 20 is just kind of sit there until we've done the completing the square bit. So we're to complete the square, you put that into brackets, and it's x minus half the number before the x, so half of 12 is 6 squared. Now if I just come back to that in a second, and we're just going to expand x minus 6 squared, so that's going to be the same as x minus 6, x minus 6, and so that creates x squared, which is great, that's what we want, minus 6x minus 6x, so minus 12x, brilliant, that's what we want, and then plus 36, that's the bit there that we don't want. So what I'm going to do straight away is get rid of that 36 that it creates, and then we've got minus 20 equals 0. So the purple bit here is exactly the same as the purple bit I've highlighted in the question. Next thing we're going to do is we're going to put that minus 36 and the minus 20 together. So we're going to rewrite this, putting those together to make minus 56 and still equals 0. It's at this point we put our lines in, because we're going to now solve this. So the first thing I want to do is add 56 to both sides. So we've got x minus 6 squared equals 56. Next thing I want to do is square root both sides to get rid of that squared. So we've got x minus 6 equals square root of 56. Now we don't often do this, but for these types of questions we need to highlight the fact that you get a plus and a minus when you square root something. Okay, next thing we need to add the 6 to get rid of that. So we've got x equals, now it's customary to put the number before the surd, before the square root, so we've got 6 plus minus root 56, which is our answer. So we've got x equals 6 plus minus root 56. Okay, so for this question you need understanding of sine, cos and tan graphs. This one's about sine graph, and you just need to know what it looks like. So point A, I know that the maximum a sine or cos graph go to is 1, and sine graph reaches that at 90 degrees. So it's going to be 90 on our x-axis and 1 on our y-axis. At point B, I know it gets there to 0 at 180, because it's 360 in total, and it reaches that 0 point halfway. So it's going to be 180 across and 0 up. Now this is quite a tricky question really. This is about graphic transformations, and there's 3 parts of this, A, B and C, and we've got to figure out, well, what's looking different with this cos graph. Well, cos normally, if I just sketch one out, normally starts at 1, goes down to 0, goes down to minus 1, and then goes back up to 1. And it does that at 90 degrees, 180 degrees it reaches its minimum, 270, and then 360 goes back up to 1. So it's between 1 and minus 1. Okay, so what's different? Well, it's slightly higher up, it's more stretched out upwards, and it's compressed to the right. Okay, so let's have a look at B first. Now, the function within, or the number within a function will affect the stretching on the x-axis. So let's have a look. Well, it normally has kind of one circuit or one period between 0 and 360. On this one, it has one here. It then does the whole thing again, and then it does the whole thing a third time. So the B is going to be 3 because it does it 3 times. Now, it might seem a bit odd that it seems to be getting compressed the higher b is. So if b was 4, it would be even more compressed. It kind of works the opposite way around within the function, within the cos, because basically at the point here, which is going to be, I think, 120, if you think about it, you type in cos 120, and then before you type in, you type in 120, but before you type in the cos, you times it by 3. The cos will think you're at 360, so it will be going up to 1 again. Anyway, okay, so that's the first bit done. So b is 3. Now, if it stretched out, say if cos looked like this, then it would be a half. So if you're only getting half a kind of full rotation, a full circuit, a full wave, whatever you want to call it, then it will be a half. Okay. The next two are quite easy because you can see on my diagram here we're between 1 and -1 normally, which is 2. Okay, and on this one between 3 and -1 we're now 4. So we've had to times it by 2 to kind of stretch it out. So we've had to times it by 2, so a is going to be 2. But you would think, well, hang on, if we timesed it by 2, then it should be between 2 and -2, but it's not. It's kind of moved up 1. And the reason for that is because we've added 1 onto it. So c is going to be 1, because it's just shifted 1 up. Not the easiest question in the world. However, with a bit of practice, you'll get there. Okay, in this question we're asked to convert that fraction with surds in it into this. Now, something I notice about what it wants me to convert it into is there's no fraction there. So that hints to me that I might need to rationalise the denominator. So I'm going to start by rationalising the denominator and basically seeing what happens. So to rationalise the denominator, all you do is you times top and bottom by the surd at the bottom. So we're going to times the top by √2. And to do that, because there's multiple terms on the top, I put them in brackets, and times √2 by √2, which is just going to be 2. Then I expand the brackets, so that's going to be square root 64, because with surds, if you times surds, you can just times the numbers and keep it in a square root, plus 50 √2, and obviously that's still over 2. I know root 64 is just 8, so it's 8 plus 50 √2 over 2. And then what I can do is just divide top and bottom by 2. Now be careful here, if there's multiple terms at the top, which there are, you've got to divide everything by 2. So that's going to be 1, that's going to be 4, and then 50 √2 is just going to be 25 √2. So that is 4 plus 25 √2. So the A, the bit at the start, is going to be 4, and the B is going to be 25.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website, on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally like we all understand why it's happened, but if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.